In this video, we'll take a look at what cream is and how it's made. We'll get to know different types of creams and examine the formulation of making creams. If you'd like to learn how cream is made properly and scientifically, stay with us until the end of this video. Creams are compound products that are made up of two phases: the oil phase and the water phase. The combination of these two phases forms the cream. But as you know, oil doesn't dissolve in water or water in oil, and they form two separate phases. That's why, to make cream, a substance called an emulsifier is used. Emulsifiers are substances that help oil and water mix together. Now, let's see why an emulsifier does this. An emulsifier has a hydrophilic or water-loving head and a hydrophobic or fat-loving tail. These substances work in such a way that, if we imagine this as a water phase and these as oil molecules, or vice versa, the water-loving heads of the emulsifier face the water phase, while the fat-loving tails point toward the oil molecules. Through this mechanism, the emulsifier enables the water phase and the oil phase to mix uniformly with each other. Creams are divided into two types: water and oil cream, or lipophilic cream; oil and water cream, or hydrophilic cream, which are also referred to as water and oil or oil and water for short. So, what are these two types? As we mentioned, creams are made up of two phases: the oil phase and the water phase. One of these phases is called the internal phase, which is dispersed as droplets within the second phase, known as the external phase. If the internal phase is made up of water and the external phase is oil, this cream is called lipophilic or water and oil. Conversely, if the internal phase is oil and the external or continuous phase is water, this cream is called hydrophilic. Now you might wonder, why do we make two types of creams? Why don't we just use one type of cream? First of all, it depends on the main ingredient or active ingredient. We need to see whether our main ingredient is water-soluble or fat-soluble. For example, if we want to make a cream whose main ingredient is vitamin C or niacinamide, since vitamin C and niacinamide are water-soluble, we need to use a hydrophilic cream. Or we might have another main ingredient like retinol or coenzyme Q10, which are fat-soluble. So, in that case, we need to make a lipophilic cream. So, one of the reasons we make two types of creams is exactly because of the main ingredient and whether it's soluble in water or oil. The second reason relates to the properties of each of these creams. For example, an oil and water cream is absorbed by the skin more quickly. It's more suitable for oily skin, and it's also used in day moisturizers and hydrating creams. On the other hand, water and oil creams, because they're oilier, are used for dry and sensitive skin, and for making night creams, or in most sunscreens, we use lipophilic creams. So up to this point, we've learned that a cream is a two-phase product. It has a water phase and an oil phase. Now, let's discuss what ingredients we need to make a cream. In the water phase, we use three types of substances: water, which should be either distilled or deionized water; polyols and preservatives; and in the oil phase, oils are used. thickeners, emulsifiers, and antioxidants. Now, as for how a cream is actually made, or what each of these ingredients are, for example, which substances are called thickeners, at what percentages they're used, and how they're made. We've explained all of this in detail in our cream making course. In this section, we'll explain the formulation for making both types of creams and provide examples as well. We'll go over it theoretically together, what percentage of which ingredients should be used. The first formulation is for a hydrophilic cream. As we mentioned, a hydrophilic cream means its internal phase is oily and its external phase is water-based. Standard practice is to consider the aqueous phase to be 50 to 70% and the oil phase to be 30 to 50%. The aqueous phase is made up of water, polyol, and a preservative. In the oil phase, there's oil, a thickener, and an emulsifier. Let me point something out. If you've looked at the previous pages, you'll notice that we used antioxidants in the oil phase, but here we haven't listed it. Why is that? Because this cream is hydrophilic, and hydrophilic creams don't need antioxidants. If a cream were lipophilic, then it would have to use antioxidants. Now, let's see what the percentages of each component are. Polyols usually make up 5 to 10% of the total amount of the cream. Preservatives, depending on the type, usually make up about 0.1% of the total amount. Thickeners make up 20 to 30% of the aqueous phase. In the example we'll go through, we'll fully explain how these percentages work, and the emulsifier makes up 3 to 6% of the total amount. Now, let's move on to the first example. We want to make a 100-gram hydrophilic cream. The main ingredient in this cream is promethazine hydrochloride. 2 grams of promethazine and 100 grams of cream. Now, this example we're giving is a medicinal cream that's used in pharmacies. So, we're going to bring this up here. Maybe pharmacy students are watching this course. We also have other examples that can be easily made at home. Now, both medicinal and cosmetic hygienic ones that we can easily use at home. You can also make this cream at home if you can find its main ingredient in the market. It's an anti-inflammatory cream. Alright, we want to make a 100-gram hydrophilic cream. Its main ingredient is 2 grams of promethazine. The first step in making a cream is always the numerical calculations. We need to see how many grams of each ingredient we want to use. First, we do the numerical calculations. Then, based on these calculations, we'll make our cream in the practical section. In this example, we want to make a 100-gram cream with 2 grams of the main ingredient. Now, in other examples, maybe we want to make a 50-gram cream. Maybe we want to make a 500-gram cream, and the main ingredient is 5 grams, or 500 milligrams. Whatever the case, the calculations are done this way. First, we need to calculate the amount of our base cream. To calculate this amount, we do it like this. In this example, we have a 100-gram cream. We need to subtract the main ingredient from it. We want to make 100 grams of hydrophilic cream. Our main ingredient is 2 grams. 100 minus 2 is 98 grams. This amount is our base cream. Now, we want 70% of this 98 grams of base cream to be the aqueous phase, and 30% of it to be the oil phase. As we mentioned in the first formulation, we have the right to use 50 to 70% aqueous phase to make hydrophilic cream, 30 to 50% oil phase, but usually we use 65 or 70% aqueous phase, and 30 to 35% oil phase. In this example, we decided to have 70% aqueous phase. These percentages all depend on our main ingredient, the materials we have, and experience. When you make a few creams, you will gradually figure out, based on the materials you have, what percentage should be aqueous phase and what percentage should be oil phase. So, out of this 98%, 70% is aqueous phase and 30% is oil phase. When we do the calculation, 70% of 98 grams comes out to 68.5 grams for the aqueous phase and 29.5 grams for the oil phase. We said that the aqueous phase is made up of 3 types of substances: water, polyol, and preservatives. In this example, we'll consider glycerin as the polyol. As we mentioned before, 3 to 6% polyol is used. In this example, we want to allocate 6% to glycerin. Our total amount is 98 grams. 6% of that is about 5.90. But we'll round that up and consider it as 6 grams. So up to this point, we have 6 grams of glycerin. The second ingredient is the preservative, and in this example, we're using methylparaben as the preservative. 1/10% of the total amount is 1/10 of a gram. In the oil phase, the first ingredient we use is the thickener. In this example, we're using beeswax. The percentage of thickener was 20 to 30% of the aqueous phase. In this example, we want to use 25% of the aqueous phase. How is that calculated? We said we have 68.5 grams of the aqueous phase. 25% of that is 17 grams. So, there's a very important point here. For the other ingredients, if you pay attention, their percentages are calculated from the total amount, but the thickener's percentage is based on the aqueous phase. The second ingredient in the oil phase is the emulsifier. In this example, we're using cetomacrogol. 4% of the total amount, which comes out to 4 grams. Again, we round this number. There are 2 more ingredients left to add to this cream. Oil, which in this example we're using liquid paraffin. To calculate the oil, we do it like this. We see how many grams of the oil phase we had. 29.5 grams in this example. We subtract the thickener, which was 17 grams, and the emulsifier, 4 grams, from the 29.5 grams. That gives us the amount of oil, and the last ingredient we need for this cream is water. To calculate the water, we do it like this as well. We subtract the polyol, meaning the glycerin we used, and the methylparaben from our 68.5 grams of the water phase. We calculate the amount of water that needs to be used in this cream, which comes out to 62.5 grams. So, for a 100-gram hydrophilic cream where the main ingredient is promethazine, 2 grams of promethazine, we need 17 grams of beeswax, 4 grams of cetomacrogol, 8.5 grams of liquid paraffin, 6 grams of glycerin, 1/10 of a gram of methylparaben, and 62.5 grams of water. This part was the numerical calculations for making the cream. In the cream making course, as we mentioned, we explained each of these ingredients and practically prepared this cream. The formulation we use to make a lipophilic cream is different from that of a hydrophilic cream. In a lipophilic cream, or what we call water in oil, this time our internal phase is the aqueous phase and our external phase is the oil phase. That's why the percentage of the oil phase is higher than the aqueous phase. Usually, the aqueous phase makes up 20 to 50% and the oil phase makes up 50 to 80%. In the aqueous phase, only water is used. Sometimes, we also use preservatives. But polyols are not used in lipophilic creams. In the oil phase, we use oil. Thickeners make up 20 to 30% of the oil phase, unlike hydrophilic creams, where 20 to 30% came from the aqueous phase, and lipophilic creams, this percentage comes from the oil phase. An emulsifier is used. It's about the same 3 to 6% of the total amount. And in lipophilic creams, we also use antioxidants. It's about 0.1%. This is because in lipophilic creams, the percentage of our oil phase is higher, and to prevent the oil from oxidizing and going bad, antioxidants are used. In this example, we want to make a 50-gram lipophilic cream whose main ingredients, or active ingredients, are 0.05 grams of histamine hydrochloride, 2.5 grams of methyl salicylate, and 0.5 grams of camphor. Based on its main ingredients, this cream is considered an analgesic and anti-inflammatory cream. If we want to make the cream, the first thing we need to do is the numerical calculations. We have 50 grams of cream. We subtract the main ingredients 0.5, 0.05, and 2.5 grams. Our cream base is 46.95 grams. Out of this amount, we plan for 65% to be the oil phase, which comes to 32.5 grams, and 35% to be the water phase, which is 14.45 grams. In the water phase, we only use water. In the oil phase, the emulsifier we're using for this cream is cetearyl alcohol as the emulsifier. 5% of the total amount comes to 2.5 grams. The thickener is another ingredient in the oil phase, and in this example, we're using beeswax. 30%, which means 30% should be multiplied by the amount of our oil phase, so 30 times 2.5 grams, which comes to about 10 grams. The antioxidant we've chosen for this cream is ascorbic acid. 0.1%, which is about 0.05 of a gram. And finally, we need to calculate our carrier oil or main oil. In this cream, we've decided to use almond oil. From the 32.5 grams that make up our oil phase, we subtract the emulsifier, thickener, and antioxidant. That leaves us with 20 grams. So, to make 50 grams of lipophilic cream with these main ingredients, we'll have 20 grams of almond oil, 10 grams of beeswax, 2.5 grams of cetearyl alcohol, 0.05 of a gram of carbic acid, and 14.5 grams of water. As I mentioned before, the method for making creams, both lipophilic and hydrophilic, and the materials used in them have been fully explained in the cream making course. Be sure to try making any cream you want, whether it's herbal, medicinal, or cosmetic. Definitely use these same calculations so you end up with a uniform and effective cream.